In this video, I'll go over an actual programming example of using Monte Carlo Simulation, using a fun problem. Suppose a panda lives in a jungle, and the jungle's roads are arranged in a grid system like a chessboard, and the panda can move around like up, down, left, or right, and even diagonally. So there are a total of 8 possible ways our panda to move, and it can also move backwards. So there are a lot of possible ways for the panda to move around. Now assume we have some coordinates where there are some danger points or holes. So when walking, if panda falls into one of those holes, it dies. So in a given day, if the panda walks randomly around the forest, what is the probability that it'll end up into one of those holes and die? In order to calculate this manually, we'll have to consider all the possible ways a panda can move around and end up into one of those holes, which is a lot of data, and it is manually impossible to figure out all the possible ways. So for our best estimation, we will use Monte Carlo Simulation, which means that we'll take some random, unbiased data and perform the probability calculation and figure out the best estimation of our probability. So for our C++ code, we included all the libraries we need for random functionality. Then we are taking a function called random walk, which will return a pair of x and y coordinates, and it takes integer input n. So firstly, we are initializing our x and y as 0 because we are starting from the center. Then we are taking an array of 8 possible directions our panda can move. So then we are taking a for loop which will run from 0 to n times, and each time it'll choose randomly a value from our direction array. So if it chooses north, our y will increase by 1. If it chooses northwest, y will increase by 1, but x will decrease by 1. So like this, we are calculating the whole possible 8 directions. And after performing the loop, it will finally return an coordinate of xy where our panda currently exists. Next, let's come to the main function of our program. We're taking a sran time null in order to use the random functionality of C++. We're taking a pair p in order to store the result of our random walk function. We're taking a counter k, and k is the counter for how many times the panda falls into one of the holes. And number of walks, we're taking 10,000 initially. Then we're taking a loop which will run from 1 to 30 times. And inside that loop, we're taking another nested loop which runs from 0 to 10,000 times. And inside, we're calling our random walk function, and we're storing the value of the function to our p pair. And then we are comparing that pair with one of the danger points we're talking about. So for our problem, we're assuming that the danger points are 4, 4, minus 4, 4, minus 4, minus 4, or 4, minus 4. So whenever p matches with any of these coordinates, we are increasing our k value by 1. And then we are finishing the loop, and this output is really not necessary, but we're still showing it in order to show our simulation. And after each iteration of I, how many times our panda falls. Then we're calculating our sample space, which is just the number of walks times 30. Then we're outputting our k value. And finally, we are calculating the probability that the panda will get killed, which is simply just k divided by our sample space or total number of walks. Then we're multiplying it with 100 in order to show the percentage. Now let's run our simulation. All right, so we got our result. Probability that the panda will get killed is 1.10133%. So let's increase our value to 50,000, and let's see if we get the same type of result. We get similar result, but this time is more accurate because the more simulation, the more accurate your results gets. And in reality, it would be pretty impossible to perform this simulation in person or physically, but it was pretty easy to write a simple C++ code or any other programming language code and run a Monte Carlo simulation to calculate this probability. So yeah, that's about it. Thank you so much for watching my video.